In this video, we are going to talk about estimating value at risk and expected shortfalls using historical approach. So the data that we are going to use is same as the data we used for variance covariance approach. So I'm just gonna copy and paste all this data into the new Excel sheet. So we have got index and 4 stocks and their returns. Daily returns are estimated. So what we are going to do in the first step to estimate the beta, which is the measure of a systematic risk of the companies. So in historical approach, instead of estimating variance covariance matrices and estimating variance of individual stocks, we just need to estimate the beta, which is the measure of systematic risk of the companies. So to estimate the beta, there are different approaches, but the easiest way is using a function which is called slope. But to illustrate what beta means, I'm going to draw a graph which represents the return of index and the stock return of Apple. So I'm going to select these two series. The first one is index and the second one is the Apple. Control Shift arrow down. So I select all the series and then insert chart and here scatter. So as you see, I have got this scatter chart which represent the daily return of index and Apple in same graph. So x-axis represent the index and y-axis represent the Apple. So for example, this specific point in the graph represent the return of Apple and index in the same day, how they move together, or this point as well. Our object here is to draw a line or fit a line which represent the nexus between the return of index and Apple. And in Excel, we can do so. So if you press this plus button here in the right top corner of the chart, you have got some options, including trend line. If you click on it, a line will be fit. This is the line, we call it OLS, ordinary least square, or regression line, which represent the relationship between the return of index and Apple. And also, if you click on this point and press more options, here you can click display equation on chart. And you have got the equation of this trend line, which is 1.17 x plus 0.0007. This 0.007 is actually the intercept, and 1.17 is the beta, which is basically the slope of this line. In other words, y, or the return of Apple, is equal to 1.176 times return of the market plus 0.0007. So as you see, we can use this line to predict expected return of the Apple, taking into account the return of the market in that day. And this number here, 1.176, is beta of Apple. Because we use daily returns, This is actually the daily beta of Apple. So this is one way to calculate the beta of individual stocks using the scatter chart. And as I said, this equation represents OLS, ordinary least square, and we can calculate this equation or estimate this coefficient directly using regression. So if you go to data and click data analysis, we have got analysis tools. We can select regression and press OK. So here we are going to select input Y range. Y is our Apple. Daily returns. So I'm going to select all these data points. And next we have got X, which is our S&P index. So we have got 1,250 almost observations, 260. So we select all of them, and then I'm going to pick up one specific cell, like here, and just press OK. So this is the regression results, and 1.17 is our coefficient, which is the beta or slope of the line, and 0.0007 is the intercept. So that's what we get here actually using the scatter. Another shortcut is to use a slope as a function. And here we can select our y's. Y is the Apple. And X is actually the returns of index. So we have got 1.175, the same results. So since the series of basically x's are going to be constant, I'm going to press F4 to put dollar before after letters. So in that case, if I copy this cell to the right, nothing is going to change. So we have got the beta of all these stocks. And also if I press to left, I would have 1. So as you know, the beta of the market is equal to 1. So the beta of individual stocks are calculated. So the next step is to calculate the beta of our portfolio. Our portfolio consists of 4 stocks. Remember, our portfolio is consisting of 4 stocks. So I'm going to put them here for a while. So remember, when we copy the formula, we always need to take into account when we copy formula, the cells also will be copied, the reference cells. And as such, it's better just paste the numbers. Anyway, so we have got the betas. I'm going to put them here. And this is our stocks in our portfolio. And the weight of stocks. Remember, we said that we allocated equal money to each. And as such, their weight is 25%. Can change it to percentage for a better look. And now I'm going to calculate portfolio beta. The portfolio beta is simply weighted average of individual stocks in our portfolio. So what I can do is to multiple weights allocated to each stock times the beta of that stock. And of course, we have got a much smarter way to estimate that one, which is using matrices. So we can use matrix multiplication. So here we have got a 1 times 4 matrix times transpose of 1 times 4 matrix. And as such, we have got the same number. So as you see, this way is much easier and straightforward. Anyway, so we have got the portfolio beta. And the next step is to see the sensitivity of our portfolio to market index. We have got daily market returns. So I'm going to copy this one and put it here. So we are going to use it. Basically, let me hide these cells, and I just need to copy paste all this data to this side of my Excel sheet. All right, so change the format to data. And here we have got the data. We have got, so what I need basically is the index return. That's what I'm looking for. And next, basically what I want is to see how the return of the portfolio is changing considering the change in market. So remember, the beta of my portfolio is 1.08, and beta is the sensitivity of our portfolio or a stock or asset to the market. So if, for example, in this date, the index is minus 0.11% negative and the beta of my portfolio is 1.08, we expect that the return of our index, the return of our portfolio be more negative comparing to the market. And as you see, this is true. All right. So we have got beta of the portfolio times the daily return of index. So I'm going to fix the beta of portfolio because it's not going to change. And then we can simply copy paste down. So this is the daily change or daily return of portfolio, taking into account systematic risk of our portfolio comparing to the market. And we can have dollar value of profit and loss because the value of our portfolio is 100 million. So we can say 100 million times the daily return. So we have got daily dollar value of profit or loss of our portfolio. So this series of numbers are historical profit loss of our portfolio, taking into account historical daily return of the market. Okay, so this is what we are looking for in historical approach to estimate value at risk. Now, what we need to do, we are going to draw a frequency table. Let's go to the data again, data analysis. We have got a histogram. So by choosing all this series of profit and loss, daily profit and loss, then we can go insert an histogram. So we have got an histogram of this profit and loss. And And as you see, it's close to normal distribution. So now, in the next step, we are interested to calculate the value at risk. The value at risk of this portfolio, taking into account the profit and loss or historical profit and loss. So what is the profit, the value at risk in the 5% and value at risk in 1% significant level. So in this case, we can use a function which is named percentile, and this function actually pick up the kth. So if you look at this function prescription, it actually explain for you. It's actually do what? So we have got an array or range of data. So the percentile value in the range of 0 and 1 would be picked up. All right. In other words, this series of data would be ranked from the smallest to the largest, and the kth item would be picked up from that series. All right. So we have got the series, and then we need to select the kth. In our case, we are looking for 0.5%. And we have got minus 1.91. So this is the value at risk in 5%. And also, for the 1%, we can say percentile. Again, select the range from up to down. This time 0.01 would be selected. So we have got the value at risks in the 1% and 5% level. Now, we are interested to estimate basically expected shortfall. So for this purpose, I need to define dummy variables in the level of 95%, or say for the expected shortfall of 5%. And this dummy variables has got, as I said, it is a binary variable equal to 0 or 1. I want to say if the profit or loss in that day is less than value at risk of 1.91, then the dummy value, the value assigned to the dummy is equal to 1, otherwise is equal to 0. All right. So for example, in case of this day, the profit and loss is minus 0.12 million, which is bigger than 1.91. So as such, the dummy variable is equal to 0. So I'm going to fix this one, F4, and then copy down. All right. In some days, for example, here, as you see, the loss is bigger than value at risk. Remember, in case of expected shortfall, the answer, we are trying to find out the answer to the question, if the profit and loss, basically the loss is going to be more than VAR, what is the expected loss, right? Value at risk of 5% tells me that with the probability of 5%, the loss is not going to be more than $1.91 million. So the question is that if the loss is going to be more than 1.91 million with the probability of 5%, what is the expected loss? And expected shortfall answer to this question, right? So we define this dummy variable, and now what is the expected shortfall in the level of 5%? We can use this function, average if these dummy variables are equal to 1. So I'm asking basically Excel to consider dummy variables of 1 and take average of those values. In other words, Excel is going to pick up the days when actually the loss has been more than value at risk of 5% and take an average. Okay, so we have got minus 3.34 million. And we can do the same for expected shortfall 1%. Average if. Okay, in the first step, we need to define a new dummy variable, which is the 1% dummy. And I'm going to copy this side. This time value at risk of 1% is our interest. And then copy down. All right. So now I'm going to use the same function, average if, but for the dummies of 1%. So average if these dummies are equal to 1. See, everything is all right. Yeah, we have got some issues here. Let me fix that issue first. So we say that average if this range is equal to 1, and in that case, take the average. Okay, there's an issue here. I'm trying to figure out what is the issue. And yes, so if, yes. So if I'm in defining dummy, I should say if this value is less than the value at risk of 1%, I'm going to fix it, then put 1, otherwise 0, and then double click to copy down. So in that case, everything will be calculated. So expected shortfall of 1% is 6.8 million, and everything is calculated now. So this is how we can end up with value at risk and expected shortfall using historical approach.